Hello, everybody. I'm coming to you live from the Math Dungeon. You'll see why I call it the Math Dungeon in a little bit and why it's kind of dark because I'm in the basement. So I thought it'd be good for this for you to see me teaching on the actual whiteboard. And I figured if I miss you, you probably miss seeing all of us teachers, maybe just a little bit, right? So you don't have this example in front of you, but today's just a catch-up day. So I figure I'll kind of read you the problem. We're just going to do one together, but I'm going to show you a real life problem with linear functions where we fill in a table, write an equation, and then graph it. I thought that might be helpful for some of you. So the real life problem is about a pizzeria. So since a lot of you are pizza winners, pizzeria charges $7 for a small cheese pizza plus $2 for each topping. So I just kind of identified that maybe the important pieces that we were going to need. And then it says, write an equation to show the relationship between the number of toppings, x. So x is the number of toppings. It says, and the cost, y, of the cheese pizza. So y is going to be our cost in dollars. So again, we're starting with a $7 cheese pizza. And if you want to add toppings, it's $2 per topping. X is going to be however many toppings we add, right? And y is going to be the cost. Okay, of the total cheese pizza with toppings on it. So there's a couple questions we're going to look through and talk through together. So one is, what's the beginning price? So if you just get a cheese pizza with nothing else on it but cheese, what would you start at? So the price would be $7, right? So we're starting with no toppings, just a cheese pizza, and it's $7. Okay, guess what? That is your y-intercept. I don't know, I'm writing so small, you probably can't even read it, right? Remember, your y-intercept is also your b. That's your starting point of, on your graph, when you guys start graphing it, that's where we're going to start our line, okay? Number two, what changes in the pizza order? So in other words, what moves? Well, the number of toppings, right, is what moves. So that's going to be our slope, all right? And we're going to kind of prove that by the table and by our graph. So let's take a look and let's fill in our table a little bit and then see if we can use the table to help us make our equation, okay? So if we have one topping, so if we got cheese pizza and we said throw in some pepperoni, that would be how much? 7 plus 2 gives us $9, right? And then let's say we get crazy and we say, all right, I want pepperoni and mushroom. Some of you might be like, ugh, that's disgusting. That's what we're getting. All right, so 7 plus 2 plus 2 more. So what's that going to be? 7 plus 2 plus 2. So we're going to be at $11, right? And we're going to keep going. We'll maybe go to 4. 4 toppings would be like a supreme, right? So 3 toppings. So some of you will be saying, well, you should do 3 times 2, right? To get 6. 6 plus the $7 would give you 13. And then some of you might be saying, well, I see a pattern going on here. So there's always lots of ways to fill in your table. You have to decide what works well for you. You might go just by the pattern, so you would know it's 15. You might be saying, well, 4 times 2 is 8, and 8 plus the 7 gives you the 15. Okay, so now we talked about our table and our real life scenario. Now we got to look into our equation. So I talked with a student on office hours about, well, why is it y equals mx plus b? And where does that come from? And it's hard to tell you on those little education videos. The x is literally this x, your x coordinate. What's changing? The number of toppings. That's your x. So that has to stay here because we don't know what it is. It's going to change each time, right? And then what's our y? Well, the y is the total cost of the pizza you're buying. So that's where your x and y come from, and those are always going to stay x and y in your equation. And Maya, shout out to you. You had an awesome question about what if we get different variables and then we use them, we're supposed to use them in an equation, but use x and y. You can use either one. So if I had like T and P for price and I used x and y by accident, you'd still get full credit as long as you're using them correctly, okay? So there's our x and our y. B, remember, is your y-intercept. Remember, I wrote it really small up here and you couldn't read it. Y-intercept is your starting point. So, like, where is our pizza starting? Well, the pizza price starts at $7. So I'm going to sub that in. I'm going to bring down my x, and I'm going to bring down my y. And then remember, m is your slope. So if m is your slope, that's your constant rate of change. So we want to look back up at our table and decide what's changing each time. So it's changing by 2. So remember I said it's a constant rate of change. Okay, you might have seen that slope is also called rise over run. And we're going to talk about that as well. We talked about it, that's the change in y over the change in x. and that triangle means change. So if I say it's the change in y, well, the y is changing by 2, and what's the x changing by? It's only going up by 1, right? It's in consecutive order. So my rise over run, or my change in y, or my change in x is 2. So my table is changing by a constant range of 2. So if this is my equation, y equals 2x plus 7, okay, so far we've taken a scenario, we filled in a table, we wrote an equation, okay? Now we're going to graph it. So if I was super tech savvy, I wouldn't have to pick this up and move it, but I'm not. I'm just a mom and a math teacher, so sorry. So here's why it's called a math dungeon, because my husband rigged up on our beams here this really awesome whiteboard coordinate grid from school. So now we're going to take our table and our equation, we're going to graph it. So if you remember, 0 toppings, okay, cost $7. So I'm going to stay by the origin on 0 for y, and I'm going to go up to 7, and that's going to be my first point. So remember, where the line crosses the x-axis, or the y-axis, that's our y-intercept. So here's my first point, okay? And then remember, 1 pizza with 1 topping, right, was an extra $2. So that makes us, instead of 7, puts us up to $9. So 1 pizza with 1 topping is $9. Then let's say I have my pizza with 2 toppings. So 2 toppings with 11. So I'm going to go up to 11. Do you see a little bit of a pattern here going on with these points? I know you're really far away, but you should be able to see it, right? And then 3 was $13. So if I have 3 toppings, and then 4 toppings is 15. If I was a little taller, I could probably keep going and see if I can get my tippy toes here. Do you see a pattern that's kind of going on with our graph? And I know it might seem like it's really far away. I'm going to kind of bring it up a little bit for you to see. Do you see the pattern that's going on here? So I'm actually going to go ahead and I'm going to start showing you what that pattern looks like. So remember, you need 3 points to make a line. So I'm going to connect those 3 points. So we're starting at our y-intercept, and we're going to go up the best I can without a straight edge. You want to connect them. You always label your line with your equation. So y equals 2x plus 7, right? And then there's that staircase design. Let me see if I got a good color marker in here. Maybe I have a red. So the staircase is rise over run. So how much we're going up and then over to the right. So I'm going up 2 and over 1. Oh, that one doesn't work that well. We'll just go with black. I'm going up 2 and over 1, up 2 and over 1, up 2 and over 1. And there's that nice staircase design. I kind of did it messy so you'd be able to see it when I move the laptop up here. You can see that slope of rising 2 and running 1 to the right. Okay? So I'm just going to put one more equation on here and talk about slope and y-intercept, because I know some kids were still kind of confused about that too. So let's say I had the equation y equals 4x minus 5. Okay, so remember, slope is always the number that's in front of the x. So this would mean my slope is 4 over 1. That would mean I'm rising 4 and I'm running 1. So that means I'm going up 4 and over 1 to the right, up 4, 1 to the right, up 4, 1 to the right. And then my y-intercept is negative 5, which means this line would start way down here on negative 5. So if I graph it, if I get this origin out of the way, I can actually start graphing it. Start down here at 1, 2, 3, 4. Here's negative 5. So again, that's my y-intercept. That's where my line crosses the y-axis. My slope is 4 over 1. So I'm going to go up 4, 1, 2, 3, 4, and over 1. I'm going to try and make the dots a little bigger for you. Up 4, 1, 2, 3, 4, and over 1. Up 4, 1, 2, 3, 4, over 1. Now, someone might say, like, well, what if you run on a graph paper going up? Well, guess what? You can do the same thing going in the opposite direction. So 1, 2, 3, 4, because I can keep going that way, right? I don't have any other lines down here. So now I'm going to connect it to the best of my ability without a ruler here. I would label it y equals 4x minus 5. And then you can see that slope of up 4 over 1, up 4 over 1. Okay? Now, you might say, like, oh, I forgot to extend this one with an arrow. Which of these lines has a steeper slope? Okay, well, let's take a peek. Does one look a little steeper than the other one? Probably this one, the 4x minus 5. How can you tell? Well, you can look at the equation, right? 4 over 1 is a higher slope than 2 over 1, right? So sometimes we're going to ask you questions like, which line has a greater slope? So you can either visually look at them to see which one is steeper, okay? You can do the little staircase like I did, or you can just look at the number that's in front of the x. All right. So again, I told a couple kids we're doing linear functions all through this month. And then part of June, we're just building on it and talking about what happens when you have 2 lines, when they intersect and stuff like that. So if you have questions, please make sure you call. Most of you are doing an amazing job at home. So keep up the hard work. And today's your catch-up day, so you can use it to watch this video and then catch up on anything else you have, probably not math, or just enjoy your day. So I hope you enjoyed seeing me, and hopefully I get to see you guys soon on our office hours. Bye, guys.